Hey Math 1B, I've got a new video for you. The fourth one from the fourth chapter. We talked about how to multiply things with polynomials last video, and this one's just a slight extension. I think you'll find this is one of the easier lessons of the entire chapter. So, what we have here are two-term polynomials being multiplied together, okay? We call it a binomial times a binomial. Now, the thing with this is, got a dead marker. Every part of this black ink polynomial needs to be multiplied by every part of the red ink polynomial. All right? Okay, see what's going on here? I got two colors. I got one polynomial in black, one polynomial in red. Here's what we got to do. What we've got to do is we need to take this x and multiply it by the red x and the plus 7, okay? So this black x term needs to multiply by both red terms here. Similarly, this negative 3 also needs to be multiplied by both the red terms. So your first step towards multiplying a binomial times a binomial, things that have multiple terms inside separated by a minus or a plus, you need to rewrite it twice, okay? And then use the distributive property. So the distributive property is pretty straightforward after that. You take x times x, which gives us x squared. You take x times 7, which gives you positive 7x. Over here, you take negative 3 times x, you get minus 3x. You take negative 3 times positive 7, gives you negative 21. And then beyond that, you just combine the like terms like you did in previous sections. So, the only thing I can combine is this plus 7x and this minus 3x. Plus 7 minus 3 gives me positive 4x. The x squared drops down, and then you're left with minus 21 here. So pretty straightforward, okay? Let's try it with number 2. If you want, pause the video and try it on your own just to see how much of an understanding you've got just after watching one example. All right, let's see if you guys are correct. So I've got my first polynomial in one color, my second polynomial in another color, and I'm just rewriting it so that each component of the black ink is multiplied by all of the parts of the red. So black 8h times red 2h minus 3. Black negative 1 times red 2h minus 3. Same idea, distributing both parts. Take 8h times 2h, it's 16. H times h is h squared. Minus 24, tag along the h. And then all you're doing is multiplying by everything by negative 1. Make it negative. Make that opposite, positive. Negative 1 times negative 3 is positive 3. Now, what you guys will notice is normally you'll just be able to simplify the middle terms when it's a 2-term times a 2-term. So negative 24h minus 2h is negative 26h. The 16h squared drops down. It cannot combine with this, nor can it combine with the 3. So my final answer is 16h squared minus 26h plus 3. All right, so the only difference here on number 3 is I added a second variable. I have an x, I have a y, I have an x, I have a y. How much is that going to change the procedure for this? It's not going to change the procedure at all. You've got one polynomial in one color, one polynomial in the other color. So every part of this one's going to be multiplied by every part of this one. So I'm going to do a rewrite first. And then distribute the 4x. I kind of like to think of this as the double distributive property because you're distributing 2 times. So 4x squared. This is going to be 36xy. Now, this is going to be 3yx. But I think you'll notice that xy and yx are exactly the same, so it's not going to be a big deal. And then you got 3 times 9 is plus 27. A y times a y is y squared. Now, just like I was saying, the commutative property states that any 2 numbers multiplied can be rearranged and it won't mess with the final result. So, yx can be rewritten as xy. And that's helpful because now I can combine it with the xy term here. So you've got 36xy plus 3xy, that gives you a positive 39xy. Your 27y squared still on the tail end here. Your 4x squareds at the front. There's your final answer. All right. Now, number 4 is a little bit different because you've got a 2-term polynomial times a 3-term polynomial. I want you to pause the video and try to do it on your own because I think your understanding from the previous 3 will easily extend to this one. So hit pause, try the first step on your own. All right. Did you write the first polynomial in black and the second in red? If you did, you are on the right track. 2a minus 9. All the black parts of 2a minus 9 are going to be distributed to all the red parts of 3a squared plus 4a minus 4. It is as simple as that. So you rewrite 2a. It's going to be multiplied by everybody in the second polynomial. So I'm just doing a rewrite. You take your negative 9. That as well is going to be multiplied by everybody in the second part. Okay. Now just make sure you keep track of all your exponents. 2a times 3a squared is going to be 6. A to the 3rd power, okay, 1 plus 2. And then you've got 8a squared, because 1 plus 1 is 2. And then you've got negative 8a. For your second polynomial, you've got negative 9 times 3a squared. You get minus 27a squared. And you know what? I started doing this a few years ago. Whenever I multiply the second group and I start to see that there's like terms already, I just stack them underneath. So instead of writing negative 9 times positive 3a squared is negative 27a squared, I write it down here below. So I'll do that in a different color just so we can keep track. So this will be the green polynomial that comes out of this. Negative 27a squared is negative 9 times 3a squared. Negative 9 times positive 4 is negative 36a. It matches up with this one. Okay? And then negative 9 times negative 4 is going to be positive 36. Now there's no constant term, so I'm going to create a new column. All right. So hopefully that's not super confusing to you guys. I basically just said instead of writing it over here, I stacked it underneath the places where I knew that they could actually combine in the end. And this is nice. All you got to do now is add the stacked columns. The 6a cubed has nobody to combine with. Positive 8 minus 27 is going to be negative 19. The a squareds, they're still a squareds. They don't change with addition and subtraction. Negative 8 minus 36 is negative 44. If they're both a's, then the result's going to be a, and then you have a positive 36 here. All right, we're rolling right through this. We've got a couple at the tail end here. Let's see if you guys can make sense of number 5. All right, number 5, we've got a trinomial times a trinomial, 3-term polynomial times another 3-term polynomial. I'd encourage you to pause it, try this one on your own. All right, if you wrote the first polynomial in one color and the second polynomial in a second color, you're on the right track. Everybody in here is going to be multiplied by all three parts in red. So you've got x squared times all three parts in red. You've got minus 4x times all three parts in red. And then you've got positive 5 times all three parts in red. All right, can you guys see all that? Just barely. Okay. So I'm going to do the same thing where after I expand it, I'm going to stack the like terms as they come out. So I got 5x to the 4. Anytime I get an x to the 4 power, I'm going to stack it right underneath here. 3x cubed. Anytime I get an x cubed power, I'm going to stack it under here. And then the same thing with the negative 4x squared. Okay? Now I'll do the second one in green marker. This will be negative 20 x to the third power. So it's going to go under here. Negative 12x squared. And then positive 16x. So there's nobody to stack this guy under, so he creates a new column. And I think I ran out of colors, so I'm just going to go with black ink on the last one. 25x squared would go under the x squared. It's positive. Plus 15x. And then minus 20, that would be a new column as well. Okay, so we'll add the stacked like terms, and that'll be our final answer. So 5x squared, it is what it is. 3 minus 20 is negative 17x cubed. Okay, so I got negative 4 minus 12. That's going to be negative 16. Plus 25 is going to be positive 9x squared. And this one's going to be plus 31x, and this one's going to be minus 20. All right, you know what? I don't think there's anything remarkable about number 16. Sorry, number 6. So I'm just going to skip that one and set you guys loose on homework. All right. Hopefully this was helpful for you guys. Please email me with any questions you may have, and enjoy polynomial multiplication, part 2.